Hello, good morning to all. Good afternoon to all. So today our topic is a medicinal chemistry, specially based on lead optimization strategy in drug design. This topic is particularly more important for the chemistry student as well as life science student because that when we are going to the research work, the more important thing is which types of compound identify for the synthesis as well as for the biological screening. So this topic is mainly input for the chemistry as well as lifestyle students. So myself, Dr. Anil Patel, Associate Professor from the Atma University, Rajkot. So these topics particularly start with the
Sorry, sir, to interrupt you.
yes.
Student will join in few minutes. Maybe our time is 2 p.m. So we will wait
Okay.
for few minutes for the student to join.
ઓકે નો પ્રોબ્લેમ નો પ્રોબ્લેમ નો પ્રોબ્લેમ બીકોઝ અહીંયા કંઈ ખ્યાલ નથી આવતો એટલે મેં કીધું સ્ટુડન્ટ નથી લાઈવ થઈ ગયું એટલે મેં કીધું ચાલુ
હા
જશે
હા 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 ઓકે ઓકે સર હું તમને સર કહીશ.
ઓકે
Good afternoon, everyone. Our next expert is Dr. Anil Patel, sir, who is Associate Professor at Department of Chemistry, Atme University, Rajkot. He will going to talk about medicinal chemistry. So welcome, sir. Over to you. Okay, sir, you can continue. સર માઇક તમારું બંધ છે સાઉન્ડ નહીં આવતું.
ઓકે નાઉ
ઓકે 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 ડન.
ઓકે good afternoon all. So today's topic is a medicinal chemistry lead optimization strategy in drug design. This topic is mainly useful for the chemistry as well as lifestyle students because when we are going for the research, the more important thing for us is lead molecules or molecules, which for chemical synthesis as well as biological testings. So this topic mainly covers the drug optimization strategies. So when we are going to the drug development process, the sequential step is the first one is a target identification. Means the discovery of specific molecules or pathway to the target with the drug. Now, after that, second is a lead discovery. Means a lead identification. So screening of some compounds to find those that interact with the target. After that, lead optimization to improve the molecule properties, maybe enhance efficacy, safety, as well as their pharmacokinetic property, means absorption, distribution, metabolism, and excretion. After that, compound is tested through the laboratory in a preclinical trials, means in vitro and in vivo. Then after we are going to see the after that we are going to see the phase one clinical trial. If the molecule pass in a preclinical test, it goes for the phase one clinical trials. At the time they take a test of the compound to the particularly healthy volunteers and check the human safety. In the second phase 2 trials, the dose as well as efficacy of the compound can be tested with the patient with disease. Then after it goes to the phase 3 clinical trials, means a large scale efficacy trial. Then in this large number of patient population can be tested. and then it goes to the phase 4, means post-marketing surveillance. Means after the drug approval, it also going for the study that can be monitoring the drug safety and effectiveness. So this is basically the drug development process, and we are going to see the special part is a lead optimization strategy. We are going to see the special part is a lead optimization strategy. So first we have to know that what is a lead compound. What is lead compound? Lead compound is a compound that has a desired biological activity with therapeutical relevance. Biological activity means the type of activity, means anti-cancer, antiviral, antibacterial, and the compound is relevance to that particular desired biological activity known as a lead compound. So lead compound is a initial chemical hit which showing a promising biological activity against a disease target. So lead identification or lead discovery is the steps for the identification of lead is types classified. Lead discovery from the natural sources, lead discovery through the random screening, as well as a non-random means a targeted focus screening, lead discovery through the drug metabolism study, lead discovery through the clinical observation, as well as lead discovery through the rational approaches. So these are the particularly how to identify lead molecules for the particular biological activity. And then after the lead modification strategies. So there are the 9 types for the lead modification strategy. First one is identify the active part of the pharmacophore. So what do you mean by, first question is what do you mean by the active part of the molecules or pharmacophore? It means that the part of the drug molecules which interact with the receptor and produce the biological activity known as a active part of the molecules known as a pharmacophore. See, the second strategy is a functional group modification. It means that we can change the functional group for improvement of their biological activity as well as their pharmacokinetic property. Third one is a structural activity relationship. Means based on the QSAR and SAR, we can check the change the functional groups. We can change the particularly by optimize the particularly molecules. After that, fourth one is a privileged structures and drug-like molecules. Means privilege means analogs of the molecules. We can synthesize a similar analogs that only the molecules have the biological relevancy or properties. Then after structure modification to increase the potency and the therapeutical index. For that, the strategy is a homologation, means we can change in the particularly molecules with the change of particularly one CH2 atoms, means a higher homologous as well as lower homologation. So we can prepare this compound similar to that higher or low homologous. Similarly, that we can change, we can prepare the branching. If the linear molecule is same, we can prepare their chain branching, means a propyl or isopropyl, butyl or isobutyl group. So we can change the particularly prepare the branch groups. Other one is a ring transformation strategy. Means if we have a particularly NN diethyl, and we can make this cyclic system, so it is called a ring chain transformation. So particularly if we have chain molecules, it converted into the ring molecules, or we can have a ring molecule, it can be converted into linear chain molecules. So this particularly is a lead modification strategy. Last one is a bioisosterism, and we are going to see that in detail, that is how the bioisosterism is important for the identify or modify the lead molecules. So first, define that bioisosterism is the procedure of the synthesis of structural analog of a lead compound by substitution of atoms or group of atoms in the parent compound for another similar electronic or steric properties particularly. So that bioisosterism is mainly important in a medicinal chemistry because it maintains a similar biological property as well as it resolve the biological problem, especially potency, side effects, it has separate biological activity and duration effects. So bioisosterism is a lead modification approach. It is a lead modification approach that has been useful for the particularly improve their toxicity, uh, improve their modified their activity of lead, as well as it is a significant role in the alteration of metabolisms. Ultimately, it can be helpful their ADMT properties or toxicity. So there are the mainly two types of bioisosters. First one is a classical bioisoster and second one is a non-classical bioisoster. So classical bioisoster means changing of particularly monovalent groups to their monovalent atoms. Means if we have a OH group, then it can be changed to the particularly there are NH2, CH3 or OR. If we have a halogen, means a fluorine we have in the molecule, then it is replaced to the chlorine, bromine, iodine, SH. This is called the classical way to the alter the groups. It is called the classical bioisoster. Similarly, in a divalent means a CH2 converted CH2 changed to the oxygen, sulfur, selenium, as well as a trivalent converted means the alkyne group can be converted into nitrile, phosphorus. Similarly, tetravalent group can be converted. So this is called a classical way of the changing of particularly groups. So it is known as a classical bioisoster. Means there are classical bioisters known is their outer their electronic configuration is almost same in the outermost orbitals. So this can be monovalent can be changed to the monovalent atom, divalent can be changed to the divalent atoms. Now, non-classical bioisoster means without regardless their electronic property, it can be electronic configurations, or it can be changed to another functional groups. Means a CO group can be changed to the carboxylic acid, sulfonamide, hydrogen, amide, ester, or amide groups. Anilytic groups can be. Similarly, we can see that if we have a halogen, then it can be converted into CF3, CN, dicyanoamine. That can be replaced. So this can be called as non-classical bioisosters. So if we have a molecules and we have to change their we have to prepare their another molecules with similar biological activity, then we can use this classical and non-classical bioisoster approach. Now there are so many examples of bioisosterism. Means a TINIB series, which has a well-known anti-cancer drug available in the market, that can be similarly designed as known as a bioisosterisms. So you can see that there are first molecules that can be illotinibs that can be useful for the cancer, lung cancer, pancreatic cancer, and this compound have particularly we can see that there are heterocyclic compound that can be quinazoline types of molecules that is similar into the definitive, which is also useful for the cancer treatments. So this is a particularly groups which have repeated in the second molecules. It is called as a bioisosters. Similarly, we can say that in a foratinib, soratinib, this have a particularly that linkage of that particularly urea linkers. So similarly, that can be a molecules which have a design based on these isosters. So these are the examples of TNIP series which have a similar example of the bioisosters. Some example of anti-cancer drug which is in the market is similarly TNIP series. We are going to see the another example in the antibacterial case. Particularly, we can see that sulfadiazine, this particularly have the pyrimidine groups. Now, in another molecules, they have replaced these pyridine molecules to the isooxazole. Isooxazole, which is in the market as a antibacterial drug, is a sulfamethaxazole. So that methoxazole. So this compound is a bioisosters of particularly sulfadiazines. Similarly, we can see that in the anti-inflammatory drug, this is a COX inhibitor, means a celecoxib. They have function. They have particularly heterocyclic core is a pyrazole. Now, in another molecules, in a valdecoxib, this particularly pyrazole replaced by the isooxazole. So this is again that other molecules part is almost similar. Thus, changing of this particularly part, it is called a isoster. So in another molecules, we can see that this part is sulfonamide part is remain same, and it is replaced by the pyridine ring system. Benzene ring replaced by the pyridine ring system, as well as isooxazole rings replaced by the pyridine ring system. So these molecules are the particularly bioisosterism of particularly molecules. So see, this is a ring isoster. Now, in the third category is analgesic. We can say this is a nicotine. These are one of the alkaloids. Now, the second molecules is we have replaced this pyridine to the particularly furan ring systems. So this can be particularly altering this pyridine ring to the furan ring systems, and the biological activity remains the same. Now, in a ranitidine, anti-ulcerative drug. Now, replacement of this furan ring system to the imidazole ring systems. So it gives a new drug is a nizatidine. So it is an anti-ulcerative drugs. Similar, we can see that ring chain transformation. Example of the ring chain transformation in a anti-histamitic drug. That we can see that here the particularly the pyrrolidine ring system is here. Now this ring system, we can remove this bond, it convert into diethylamide. As well as we can change this ethyl to the methyl. So compound A has a twice activity than C and many times greater activity than B. So compound, so by transferring the ring to chain or chain to ring alter their biological activity. Now, another examples of particularly bioisosters is anti-aminopyrines. Aminopyrine is an antipyrine drug that particularly marketed in 1896. So it can be removed from the market because of their carcinogenic properties. So after that, to remove their toxicological part of the molecules through the bioisosteric modifications, this particularly NN dimethyl part substitution is removed to the particularly isopropyl groups, and this particularly propyl phenazone molecules have a no carcinogenic actions. So it is developed by the Roche in 1951 through the bioisosteric modification. So that from that we can see that the molecules modification through the isosterism approach, it gives a more potent or as well as less toxic molecules. So this modification strategy is useful for the lead modifications. Now, This is the first classification of cytotoxic or anti-cancer agent. There are mainly four types of classification: alkylating agent, antimetabolite, particularly, as well as mitotinic inhibitor, as well as topoisomerase inhibitor. But we are going to see the particularly the one paper that can be showing the modification isoster through the bioisosters. So here we are going to see the mainly alkylating agent modification. First we are going to see the N-mustard, and then after we are going to see the bis-hydroxymethyl pyrrole derivative modification through the isosters. So for our first examples is a modification on the nitrogen mustard molecules. So this one, first one, sorry, this particularly in this slide, the uridomustine is a BO1055 is a water soluble nitrogen mustard compound, is a potential anti-cancer agent. This molecule is found to be a very good active against a various cancer cell line, and this molecule was reported by the Dr. Noel Kapuria and their groups in a bioorganic medicinal chemistry in a particularly 2011. So after that, in particularly our lab, the Dr. Satish Tara has modified this particularly uridomustine to the particularly BO2095. He changed this particularly CONH group to NHCO group. So he prepared the bioisoster approach and modified these lead molecules BO1055 to BO2095. This compound have also similar water solubility and more potency compared to the BO1055. So this compound is published by the Dr. Satish Tara in European Journal of Medicinal Chemistry in 2014. So this is one of the best approach for the drug modification, means a lead modification. If once we have lead molecules like this BO1055, then we can modify to this BO2095 by just changing of this part CONH to NHCO. So this is one of the good approach for the lead modifications. Now there are the examples. First we are going to see how we can modify this DNA alkylating agent. So we have several examples as a mitomycin C, this is a erythrosins. These are the particularly molecules which have a DNA alkylating agent and it produce a very good anti-cancer activity. So that we can see that here compound 4 is a diol molecules. So compound 5 is a similarly that it can be a diol or this is getting a amide molecules. So based on this particularly mechanism, we can modify some molecules. So for that we can see the first mitomycin drug mechanism study. When mitomycin goes into our body, it converted into that particularly aziridinomycins. Then after when it interact with our DNA, then it go to the DNA cross-linking edit. So when these types of particularly molecule is present, it can be converted into the DNA. This DNA is binding with ear. It can be a DNA cross-linking to the intrastate or interstate. So the reported proposed mechanism for this DNA cross-linking of particularly this bis-hydroxymethyl compounds, then when it interacts with DNA, it undergoes these types of molecules and it can be a DNA bind with our compounds. So based on these mechanisms, we can design new molecules with similar biological actions. we can see in the slide that particularly in a particular case, the one of the researcher has published these IPP compounds. These IPP compounds is interact with the DNA, means the part of our DNA is a guanine is a sequencing systems. So it interact with these types of binding with the DNA. It produces DNA adapt is a pyrrolizine derivatives. So these compounds is known as the IPP compounds and which bind with the in our DNA part. So it can be isolated in particularly from the when we are going to see the biological screening in vivo, then it is isolated product and we can see that the structure of the isolated product is that can be binded with the DNA with the our compound number 18. So based on this mechanism in our groups, they have designed several molecules. So we can see that in a scheme one of anti-tumor bihydroxymethyl pyrrolidine molecules and analogs based on this particularly structure. Based on this particularly structure, there are the several molecules is synthesized. We can see that starting with the imidazole, pyrrole, so fused ring system, pyrrole, as well as fused with the pyrrole fused with the another heterocyclic ring systems. Especially we can see that here it is bind with the beta carbolane systems. Now I have highlighted in a red color with the schemes because we are going to see this particularly strategy, the bioisosterism strategy for the modification of the lead molecules. So particularly we are going to see that particularly part of this highlighted in a red color. So this one is a lead modification strategy. First one we have these types of compound. This compound can be modified by these strategies, and there are several compound reported based on these modification strategies. So how the particularly pyrrolothalazine compound can be synthesized. So this is our target molecules. So how their design can be possible. So we have break down this particularly into two pharmacophore. First one is a thalazine and second one is a bis-hydroxymethyl pyrrole. Because we know that this bis-hydroxymethyl pyrrole derivatives bind with the DNA. In the previous slide, we have seen this type of particularly part is a bind with or interact with the DNA and produce a anti-cancer activity. So that we have hybriding the two pharmacophore. Here we have selected one pharmacophore as a thalazine and second pharmacophore as a bis-hydroxymethyl pyrrole, and we have designed particularly this bis-hydroxymethyl pyrrole or thalazine derivatives. So this is the first design based on only on paper. Now the task is how to synthesize this molecule. So we have proposed particular schemes based on starting with the thalazine molecules, means the chlorothalazine molecules. First, in the first slide, the chlorothalazine is replaced with the secondary amines, different types of secondary amines. Then after this react, particularly compound 26A2D react with TMSN in the presence of Lewis acid as AlCl3 and acetyl chloride. So it particularly gives a cyano derivative at, nearby the nitrogen atom as well as acetyl group on the nitrogen atoms. So these compounds later on particularly react with HBF4 in acetic acid, particularly it gives a cyclic complex, which on particularly Diels-Alder reaction with the DMAD, dimethoxyacetylene diacetate, particular dimethylacetylene diacetate, which react with the DMAD Through the Diels-Alder reactions, in a DMF at 100 degree, it produces diesters, means at 28 A2D. Later on, its compound is reduced to the diol by using a lithium aluminum hydride in ether, and later on this is for our targeted molecules because it also interact with the DNA and produce a DNA adduct, as we have seen in a earlier slide that IPP is interact with the DNA through the DNA cross-linking and it produce a DNA adduct. Similarly, that we have replaced this OH group to the isocyanate R2NCO means ethyl isocyanate or isopropyl isocyanates. So here the ethyl and isocyanate. So we have a targeted molecules as a 29A2D as well as a 30A2D as well as a 31A2D. So these are the targeted molecules for the anti-cancer screenings. So we can see the result of these particularly targeted molecules. Similar to the mechanism of mitomycin C, it can be interact with our DNA through the cross-linking mechanism via SN1 electrophilic reactions, means bis-hydroxymethylpyrrole derivatives bind with DNA through the DNA alkylations. So how the DNA alkylation take place in a particularly molecules that have been seen through the particularly study through the DNA interested close linking. Here we can see that this is ICL intrastrain cross linking. This is a single strain cross linking. So here first one is a marker, second one is a control. We have take a melphalan as a standard molecules and we have checked that this 29D. This 29D we have take the particularly here the heterocyclic is a bipyridine ring and here the diol system. So you can see that in a particularly the different concentration of 29D 0.1 micromolar to the 1 micromolar, we can see that with the increasing the concentrations, it increasing the intrastrain cross linkings. Here we can say that. This is our standard drug for the melphalan. It through the 1 micromolar it gives us this types of cross linking, but here we can see that it is so the very stronger DNA cross linking compared to the with the standard drug melphalan. So this proposed through these proposed mechanisms, our molecules similar to the bind with the DNA through the intrastrain cross linkings. So we can see that 0.1 micromolar to the 1 micromolar. If 1 micromolar is shows a very strong cross linking comparison with the melphalan drugs. So that this is a particular design of the molecules similar to the mitomycin biological activity. Mitomycin C biological activity it interact with the DNA and bind with the DNA and produce the anti-cancer activity. So this particular paper we have published in Journal of Medicinal Chemistry in 2019. See that this particular paper we have published in 2019. So that this particularly show the inhibit angiogenesis activity as well as induce a DNA intrastrain cross linkings. Now, if we find this compound as a lead molecules, because it gives a very good activity and very good DNA binding property, so we can modify these molecules to give the more potency comparison with this lead compound. So after that, we have a particularly one bioisosterism approach that this compound we have already published in 2019 in the Journal of Medicinal Chemistry, and this shows a very good promising activity. So we can modify this compound by using a benzology approach. Benzology approach means addition of one benzene group or removal of one benzene group from the molecules. This is called as a benzology molecules approach. So this is a one types of bioisoster approach that can be particularly ring can be added. So through this ring adding, it alter their lipophilic property, means it alter their particularly pharmacokinetic properties. So this comes in our mind, and we have modified these molecules. Now again, we have a near task that how we can synthesize these molecules. Any retrosynthesis method for these compounds can be possible or not. These are our target molecules now. So we have designed this through this scheme that firstly we have take the anhydride. In this anhydride can be react with the hydrogen hydrate, it produce a benzothiazidone molecules, particularly the attached benzene rings. After that, this compound number 13 react with particularly POCl3 in the presence of pyridine, it converted into the dichloride. So this ketone is converted into the OH, as further it can be converted into the chlorine groups. So this dichlorobenzothiazine molecules later on replace one chlorine atom with the different particularly primary or secondary amides. So here we have take particularly dimethyl, diethyl, as well as pyrrolidine, piperidine, morpholine, and as well as bipyridine. Because in earlier our research paper, we have identified that bipyridine molecules is has produced a most promising biological activity. So we have again we check this particularly for the in these schemes also. So this 15A to E have one chlorine atoms and one particularly substitution as a R1 is upper side. So now this chlorine atom, we have to remove this chlorine atom from the molecules because we require a hydrogen atom for the sinus atoms. If we have to prepare the pyro ring system here, then we have to remove this chlorine. So in this chlorine we have removed through the palladium carbon in a methanol, it removed the dechlorinations and it produces a hydrogen atoms. It is 16A2E. After that, similar to the earlier schemes, we have used a TMSCN as well as ALCS is a catalyst and acetyl chloride in a DCM at a room temperature, it converted into the acetyl group as a nitrogen atoms as well as a nearby position of the cyano groups. Now, similar to the earlier method, this particularly 17A to E converted into the HBF4 salt, which further on a diacider reactor with the dimethyl acetylene dicarboxylates, it in the DMF at 100 degree gives a diester molecules. So this pyrrole contain these diester molecules. Now these diester molecules particularly react with lithium aluminum hydride in the ether and DCM, it will converted into the diol. So our first 19A2A target molecules is a diol because bis-hydroxy pyrrole is a particularly produce a promising activity. So we have prepared this diol as a 19A2E, and then after this diol we have converted into the ethyl isocyanate to the ethyl carbamate. So here 28 is a carbamate molecules. The reaction is also produced in a room temperatures. So you can see that now this 29A to E means a diol, particularly tested against various cell lines, means colon cell line HCT116, pancreatic cell line part IS1, as well as renal cancer cell line 7864. So we can see that this whole compound 19A to E, whole compound gives a promising biological activity comparison with the reference standard as a cisplatin, irinotecan, as well as sorafenib. This we have taken these three as a reference drug. So this IC50 value, see, we can see that it shows in a very promising biological activity in a micromolar range. So we can see that 90A gives a 0.65, as well as in a particularly colorectal means cancer cell line HCT116, as well it is gives a 0.37 micromolar in a 7864, particularly renal cancer cell line. So say this 90A gives a promising biological activity. Similarly, 19B and 19E gives a very promising biological activity. So we have checked these molecules. We have particularly checked these molecules through the DNA intrastrand cross-linking study through the electrophoretic methods. So similar to the earlier, here we have taken a 1 micromolar and 5 micromolar concentration of melphalan drug as a reference standard, and we have checked all these 5 compounds 19A to E at 37 degree for the particularly incubation with the various concentration for the DNA binding study. After the linearization and digestion with the particularly, the DNA was denatured under alkaline conditions, and we have seen that the intrastrand cross-linking in single strand particularly through this particularly image. So we can see that this 19A in a particularly, yes, we can see that in a 1 micromolar concentration in a drug standard drug melphalan in our compound 19A gives a promising biological activity. Similar to that particularly in a 19B, 19C, 19E, these all four molecules gives a very good DNA intrastrand cross-linking activity. So through this electrophoresis methods, we can identify that our compound have a good DNA interstrand cross-linking activity. Next, so particularly these molecules we have particularly published in JMC again in 2021. So similar to the earlier research work, we have benzology molecules from our previously identified lead molecules, and we have checked these molecules in a particularly anti-cancer activity through the oral mechanisms, and it gives a very good anti-angiogenesis activity as well as DNA cross-linking. So how the this shows the how we can modify the lead molecules, or we can modify the any compounds. Now after what that, We have keep our mind that these pyrrole groups are very good DNA cross-linking activity. So we have designed two types of molecules. First one is we have taken another pharmacophore as a phenanthridine, and secondly we have taken the pharmacophore as a diphenjoisoprene. This pharmacophore we have taken from the alkaloid, that these types of alkaloid produce a very good anti-cancer activity, and we have also there is a several reference that is phenanthridine also gives a very good anti-cancer activity. So our target is we have to combine this pharmacophore to produce a pyrrolophenanthridine as well as dihydropyrroloisoquinone derivative. So this one is a class 1 compound and this one is a class 2 compound. So how we can retrosynthesis of this method? Any particularly scheme, designing the schemes. So for the class 1, we have taken a starting material as a phenanthridine. Now we have a task that we required here hydrogen as a R1 as well as we require a substitution as a R1. So for that, if we require a hydrogen at particularly position at the R1, we have a react this phenanthridine to the bromoacetic acid. Now prepare this bromoacetic acid salt, and then after it directly react with the DMAD, it gives a diester, but without any substitutions at R1 position, which at the time of this R1 is a hydrogens. Then after in a second way, this compound number 70 react with similar to the earlier method, the TMSCN in the presence of AlCl3 as a catalyst and in a dichloromethane solvent, and react with the acetyl chloride, different acetyl or benzyl chloride. So through this compound number 9B2F react with the HBF4 salt, and in similar in situ it react with the DMAD at 100-degree DMF, it produces a diester. So now we get diester with hydrogen as well as other substitutions. Means the substitution is alkyl as well as benzyl substitution. So we have taken the particularly substitution as a 4-fluoro and 4-methoxy, because we have to identify this is a alkyl as well as benzyl, which groups is a particularly gives a very good biological activity. So we have taken this 4-fluoro and 4-methoxy to check their electronic effect, means electron withdrawing effect as well as electron donating effect. So after that 20A to F react with lithium aluminum hydride, reduce under the condition of lithium aluminum hydride, it produces a diol compounds. Now earlier we have seen that this diol gives a good promising activity, but we have also seen that so carbamide also gives us similar types of biological activity. So we have taken ethyl isocyanate as well as isopropyl isocyanate, and we prepared another 6 molecules of the particularly carbamate of ethyl as well as isopropyl derivatives. So this is particularly class 1 scheme. After that, we have a design of particularly class 2 series, but this is a very long scheme. Initially we have taken a phenanthridine aldehyde as a starting material, then this phenanthridine aldehyde 24 number compound reduced to get aldehyde to alcohol by using sodium borohydride. This alcohol later on reduced to the bromine by using PbR3 in a dichloromethanes. Now this compound number 26 react with the protected glycine derivative. Protected glycine derivative means this protection through the benzophenone. So it gives a particularly compound number 27. Later on, this compound number 27 react with the hydrochloric acid in a ethyl acetate. It gives a particularly amino groups, means a D protection is there. Now this particularly compound number 28 react with the formaldehyde. This is a particularly Pictet-Spengler reactions. So it converted into the particularly isoquinoline derivatives, dibenzoisoquinoline. Now this NH group is react with different types of acetyl chloride or acetic anhydrides. In the TEA and solvent is a THF at room temperature, it produces a particularly N-acetyl derivative product, N-acetyl or N-benzyl derivative, because we have taken acetyl as well as benzyl derivatives. So this compound 31A to E, I get through the hydrolysis of this particularly ester in a ethanol and one normal anhydride. Now this acid and the N-acetyl groups react with the DMAD at 100 degree, it gives a diesters. Now again, earlier in our similar to this mechanism, this diester converted into the diol by the reduction of lithium aluminum hydride in ether and dichloromethanes. So we have synthesized these 5 molecules. In this we have taken a methyl ethyl benzyl as well as a substituted benzene derivatives. So we have checked particularly in both series compound 20, all compound tested against various cancer cell lines. But among that I have represented here that 21A, 21B, 31A and 31B comparison with the cisplatin in 4 different cancer cell lines. Here we can see that particularly all the compound showing a promising anti-cancer activity comparison with the standard drug cisplatins. Again, we have checked the DNA cross-linking mechanisms to the electrophoresis, and we have taken a melphalan as a standard drug, and concentration we have taken a 1 and 5 micromolar. Then after we can see that 21A and 21B as well as 31A and 31B. 31A and 31B shows a very promising interest and cross-linking mechanisms. And this we can see in the particularly image here that 1 micromolar of particularly 33A give the promising interest and cross-linking activity. So that similarly 33B also showing that in 1 micromolar it is showing up very good promising. So with the concentration increasing, it also gives a very good interest and cross-linking. So over all 4 molecules showing the very good DNA cross-linking activity. Then after we have also checked their mechanism for the cell cycle inhibitions. For that we have see that 21A compounds is particularly arrest in the G2M phase. So this we can see that in 3 different time interval after 24 hours, after 48 hours, and after 72 hours. And we can say that it's particularly 21A first was a G2M phase accumulation. First is going to the G2M phase accumulation, then after it goes into the G1 arrested after 72 hours. This observation indicates that the compound 21A targets the DNA and induce the several DNA damage and triggers the apoptotic cell death. So this is a particularly mechanism so that how the cell cycle inhibition take place. We have also checked the induction of apoptosis. So to confirm the compound A compound with the cell death, we have checked this annexidine V binding assay in a particularly H460 cells. Now this compound 21A with the various three concentrations 1.5, 3.0 and 6 micromolar treated 48 hours, and after in the shown in a figure, particularly, there is a significant time dependent increase in the percentage of NXV cells. We can see that in a control there is a particularly this cell particularly, and then after we can see that in a 6 micromolar concentration it is particularly 80% apoptotic cells, which is more than the standard drug cisplatin. This is a more than the standard drug cisplatin, in particularly H460 cells. So it induced the apoptosis. Then after we have checked in vivo study of the compound 21A, and we say that approximately 66 and 72% of tumor growth compared to the vehicle control in H460 and HCT116 xenograph models. So this we have compound checked in the particularly in mice models. First one we have checked in H460, then after HCT116. So here we have also checked their particularly body weight, mice body weight. So in a particularly uh, tumor size reduced approximately 34 to 40% in the mice treated with the oxyplenins, and our compound particularly reduces 66 to 72% tumor growth. So it shows that our compound is a very good anti-tumor agent in a particularly H46 as well as HCT116 xenografts. So this gives a very good in vivo activity in a particularly HCT116 as well as H460 cancer cells. So this data we have published in the European Journal of Medicinal Chemistry in the 2020. So this shows that how the designing can be possible through the lead modifications. So these three papers we have already published in a very reputed journals, in the Journal of Medicinal Chemistry as well as European Journal of Medicinal Chemistry. So that's all. Thank you.
Thank you so much, sir, for enlightening us with your expertise and knowledge. We are honored to have you with us. Kindly share your PPT with us.
Yes, also thank you.
Okay, thank you.